Hello, and welcome to Calculus Lesson 118. Today we're going to talk about limaçon and lemon skates. Basically, these are the beautiful rose curves that we've already seen in a couple of different forms. So let's zoom in and get started. So in general, a rose curve will have the general equation r equals we'll go with c sine of n theta, or r equals c, did I use d? No. Cosine of n theta, where c is a constant, n is a constant, and that gives us our rose curve. But the limaçon, and it's actually got one of those fun French C's there. A limaçon basically has an additional piece, and that is that they either add some constant to our rose curve, or let's see here, a plus or minus b cosine theta. So now there is a constant added. What happens if this constant is really big? Well, then that constant takes over and you basically get a circle, right? R equals a constant is a circle if we're graphing in the polar plane. But if r is kind of small, then the sine will sometimes take over, or if a is kind of small, the sine will sometimes take over and the a will sometimes take over. So here is the quick look, or the general rule for these. The general rule is this. If you have a over b less than 1, or simply a is less than b, that means that your a is not enough to overtake the sine or cosine function, then you're going to get a limaçon that looks something like this. Let's see if I can do it justice today. Might be a little exaggerated. Your book has a great picture on page 604. And then obviously after every 360, it just repeats itself again. So no need to draw that. Now if a over b equals 1, we have this thing called a cardioid. And it's called that because it looks like a certain organ called the heart. And those match up. There we go. So that's a cardioid. If we have between 1 and 2, we have a dimpled limaçon. It has a little dimple right there. But I think I've over-exaggerated that one a little bit. It's just very slight. It dips down and then it comes back. Now, if a over b is greater than 2, what you get is that the a, the constant, takes over and it looks more circle-like. And then you just get like a little flat part kind of on one side. Okay? So that is that. These are your limaçons. So you're going to be responsible for graphing these. They're going to give you the equation. How do you graph it? Well, I would suggest making a table. You're going to plug in angles, and you're going to get R values out. I would recommend starting with 0, pi over 2, pi, 3 pi over 2, and 2 pi. That gets you all the way to 360 degrees, or 2 pi, all the way around the circle. You're going to capture whatever's going on in this periodic function before you get to 2 pi anyways. So that is perfect. Any more than that, and then you're just doing extra work. Why? Because these patterns repeat themselves over and over and over again. That's just like our lives, right? Like we constantly repeat the same things over again unless we take drastic action to change it. And so if you're in a pattern of sin right now, then likely that's going to continue unless you do something about it. Similarly, if you're in a pattern of righteousness where you're seeking the Lord and that's part of your daily routine, then that's going to continue. And that's such a great thing. So I would encourage you to do that. Now let's talk about the lemon skates. These are a different form of these graphs. Again, we start with the basic Rose curve, but in this case, we have r squared equals a sine of n theta, or r squared equals a cosine of n theta. So, what does this mean for us? Well, it means a couple of things. First of all, it's weird to have an r squared equal something. So, when we're plugging in our angles, if we get negative numbers out, r squared will never equal that, so we don't graph it. Let's look at this. These are a little bit trickier to get. So, we are going to graph the lemon skate. Flipping page. Here we go. R squared equals 4 cosine 2 theta. So our first step is to draw the table. We're going to have theta on one side and r squared on the other. What should my values of theta be? Well, I know it's actually going to, well, I'm just going to do the normal ones. Why would I do anything else? Okay, so 4 cosine of 0 looks like 4. If r squared equals 4, then r equals 2. Right? It's simply the square root of r squared. If I plug in pi over 2, I get cosine of pi, which is negative 1. So this looks like negative 4. Oh, I have a problem, don't I? Well, my problem is that unfortunately, I can't take the square root of negative 4. Okay? So I'm going to leave that one as unknown. So all I know at this point is as I start at, we'll graph right here. As I start at theta equals 0, I'm at radius 2. And then, I really don't know much, but I know it's undefined at pi over 2. So maybe I need to add in an additional point here, pi over 4. That's fine. I'll just do a little bit more work here. Pi over 4, what is cosine of 2 times pi over 4? That's cosine of pi over 2, which is 0. The square root of 0 is 0. So I know by the time I get to 45 degrees, which is right here, I know that my function is already 0. So I get something like that, just one petal of that leaf. Then, if I were to continue graphing the r squared, it would, right, because I was going down to negative 4, it would come down this way. The reason why I'm removing that leaf and not including it is because I can't take the square root of negative numbers. So when I get to 3 pi over 4, that is also 0. And so the square root of 0 is 0. So I'm back here. That's my 3 pi over 4 line. From there, I should be able to get something. So let's go to pi now. What is cosine of 2 pi? Well, it's 1. 4 times 1 is 4. So that means the square root is 2. So I'm going to go 2 in the pi direction. And then, as I do this guy, which will be 5 pi over 4, I can see the pattern now. I've already worked through a couple of them, so I get that it's going to loop this way. Now, if I were to continue plugging in numbers, it would give me, for all of these angles down here, it would give me negative values, which would be this loop. And then, for these values, it'll give me a positive right there. The issue is that since it's r squared, I'm not going to get all 4 petals of this rose that I would normally expect. I will lose these because I cannot take the square root of a negative number. And so, goofy as it may be, that is my lemon skate. That, my friends, is problem set 118.